Imagine burning $125 million in the atmosphere just because someone forgot to check their calculator.
It sounds like a bad joke, Mark, but that is exactly what happened to the Mars Climate Orbiter. It remains the most embarrassing failure in the history of space exploration.
We aren't talking about a complex engine failure or a random meteorite strike here. We are talking about a spacecraft that traveled 416 million miles perfectly, only to die because of fourth-grade arithmetic.
This was the crown jewel of NASA's faster, better, cheaper era. But in the end, a simple communication breakdown between Lockheed Martin and the Jet Propulsion Laboratory turned it into a pile of molten debris.
The physics of the crash were brutal. The orbiter was supposed to skim over the planet at a safe altitude. Instead, it slammed into the Martian atmosphere at 5 kilometers per second.
And the reason? One team of engineers was working in English Imperial units, calculating force in pounds. The other team was working in metric, calculating force in newtons.
That is a massive difference. 1 pound is about 4.45 newtons. So every time the thrusters fired, the computer thought the force was small, but in reality, it was nearly 5 times stronger.
For 9 months, the spacecraft was drifting off course inch by inch, and nobody realized that the software was speaking 2 completely different languages.
When the spacecraft went behind Mars for the orbital insertion, Mission Control expected a signal blackout of 20 minutes. They waited, they prayed, and they stared at the static.
But the signal never came back. The orbiter didn't just miss its target, it disintegrated. It hit the upper atmosphere so low and so fast that the friction turned the aluminum structure into fireworks.
It hit an altitude of 57 kilometers. If it had been just 30 kilometers higher, the mission would have been a success. But math is unforgiving, and gravity doesn't offer second chances.
The investigation was humiliating. It revealed that navigators actually saw warning signs months in advance, but dismissed them as minor glitches or background noise.
They called it the small forces data. They looked at the numbers and assumed they were right, never suspecting that the fundamental unit of measurement was wrong from the start.
This wasn't a technical failure, it was a management failure. It proved that you can have the smartest rocket scientists in the world, but if they don't talk to each other, you end up with a very expensive crater.
So, buckle up. We are going to dissect how a simple unit conversion error destroyed a masterpiece of engineering and changed aerospace protocols forever.
The seed of this disaster wasn't planted in space. It was planted in a contract negotiation between the Jet Propulsion Laboratory in Pasadena and Lockheed Martin in Denver. We call it interface confusion. But that's just corporate speak for nobody agreed on the language. You have to understand the era. Mark, this was the late 90s. The golden era. At NASA, faster, better, cheaper. That was the cut the fat, cut the testing time, cut the budget. The Mars Climate Orbiter was built on a shoestring compared to the Vikings or the Voyagers. When you cut budgets, you cut the people who double-check the double-checkers. You rely on heritage code, you rely on assumptions, and Lockheed assumed that since they built the hardware, they could use their native units.
Let's talk about the hardware. The spacecraft had unbalanced reaction wheels. To keep the orbiter steady, the thrusters had to fire frequently, much more frequently than we usually like. We call this angular momentum desaturation, or AMD. Every time a thruster fires, it imparts a specific amount of force over a specific amount of time. In physics, we call this impulse. Impulse equals force multiplied by time. It's a vector. It changes where you are going. The navigation team needs to know exactly how much impulse was generated so they can update their mathematical model of where the spacecraft is relative to Mars. If the model is wrong, the navigation is wrong. It's dead reckoning in the vacuum.
Here is where the paperwork killed the machine. There was a specific file transfer protocol. The software interface specification, the SIS, explicitly stated that all data must be in metric units, newtons. But the software engineers at Lockheed, working on the ground station code, used existing legacy code from previous missions. That code calculated the thruster force in pounds force. Nobody flagged it. There was no conversion algorithm. So the computer spit out a number. Let's say the number was 1. To Lockheed, that meant 1 pound force second. They sent that file to JPL. The JPL navigation software ingested that one and read it as 1 Newton second.
And that is the mathematical violence. 1 pound force is equal to 4.45 newtons. The difference is massive. It's not a rounding error, it's a multiplier. Every time the thrusters fired to desaturate the wheels, the JPL navigation computer thought the push was small, gentle, a nudge. In reality, the spacecraft was being shoved with 4.45 times the force the computer expected. It's like tapping the gas pedal thinking you're in a Honda Civic, but you're actually driving a dragster. You are going to overshoot.
This happened continuously for 9 months. It wasn't a one-time glitch. It was a cumulative, compounding error. The navigators at JPL actually saw something was wrong. They are the best in the world at this. They noticed the line of sight residuals were off. The Doppler shift in the radio signal didn't match the prediction. The spacecraft was drifting. They even filled out an ISA, an Incident Surprise Anomaly report. They flagged it. Something is pushing the spacecraft more than it should.
But they didn't know what was pushing it. They thought it might be outgassing from the insulation. They thought it might be an error in how they modeled the pressure of sunlight hitting the solar panels. Solar radiation. Pressure is tricky. They scrutinized the physics of the stars, but they never scrutinized the units of the file. It was too stupid to consider. Who sends Imperial units to NASA in 1999? It's like sending a fax to a smartphone. The navigators debated it, but the management at the project level dismissed the anomaly as within acceptable noise. They trusted the model over the raw data. They trusted the contract over the reality.
Communication breakdown is expensive. The teams were isolated, different states, different cultures. Lockheed Martin was the contractor. They were defensive. JPL was the client. They were arrogant. There was no integrated end-to-end test of this specific data flow. They tested the engines, they tested the radio, but they never ran a simulation where the Lockheed ground software actually fed data to the JPL navigation software until the mission was already flying. If they had done that test once on the ground, the spacecraft would have crashed in the simulator and we would have fixed it for free. Instead, we waited until the spacecraft was millions of miles away to find out that 1 does not equal 4.45.
By the time the orbiter approached Mars, the trajectory was fatal. The target altitude for orbital insertion, the point where the engines fire to get captured by gravity, was supposed to be 226 kilometers. Safe, high above the atmosphere. But because of the extra push from the unit error, the spacecraft was actually on a trajectory to hit 57 kilometers, that is deep inside the Martian atmosphere. At that speed, the atmosphere isn't gas, it's plasma. It acts like a blowtorch. The heat shield wasn't designed for that entry angle. The engines fired to slow down, but it didn't matter. The spacecraft dipped into the air, tumbled, overheated, and ripped itself apart. It was a perfectly functioning machine, piloted by bad math into a suicide run.
The morning after, the silence was deafening. The initial confusion turned into horror as the data came in. We didn't just lose a satellite, we lost it in the most embarrassing way possible. When the investigation board released their findings, the headline wasn't complex failure. It was metric mix-up. The media tore us apart. NASA crashes probe because they can't convert pounds to newtons. It made rocket scientists look like high school dropouts. The total cost of the mission was $327.6 million. The orbiter itself was $193.1 million, lost in a single second. But the cost to NASA's reputation was incalculable. It effectively killed the faster, better, cheaper philosophy. It proved that you can't cut corners on verification.
There is no forgiveness in physics. Gravity doesn't care about your budget. Friction doesn't care about your intent. If you get the numbers wrong, you die. It's that simple. This wasn't a tragedy of circumstance. It was a tragedy of negligence. The engineers at Lockheed who wrote the code, they failed. The engineers at JPL who didn't validate the data, they failed. The managers who ignored the ISA reports, they failed. It was a systemic collapse of rigor. We got comfortable. We thought spaceflight was routine. Spaceflight is never routine. It requires paranoia. You have to assume everything is wrong until you prove it is right.
The fallout changed the industry forever. Now every single data interface document is scrutinized. We have software that automatically flags unit discrepancies. We have context metadata attached to every number. You can't just send a 5 anymore. You have to send 5 Newton meters. The International System of Units, SI, became mandatory and non-negotiable for all future contracts. Lockheed Martin had to eat a significant amount of humble pie, and JPL had to restructure its entire mission assurance process. We learned that verification isn't just a box you check, it's a survival mechanism. It's the most expensive math lesson in history. We paid $300 million to learn that we need to talk to each other. We learned that 2 teams working in silos creates a blind spot big enough to hide a planet. The legacy of the MCO isn't science. It's a case study in management failure. It teaches us that the most dangerous part of a space mission isn't the launch, or the radiation, or the vacuum. It's the assumption that someone else checked the math.
The Mars Climate Orbiter is now a debris field scattered across the Martian surface, or perhaps dust in the upper atmosphere. It never sent back a single weather report. It never relayed a single byte of data from the polar lander, which, by the way, crashed a few months later due to another software error. 1999 was a graveyard year for Mars, but that crater is a monument. It stands as a warning to every junior engineer who opens a spreadsheet. Details matter. Units matter. In the end, the universe is strictly metric. If you try to speak Imperial to a planet, it will silence you permanently.